We have here the graph of the parabola. So f of x equals x minus 3, x plus 2. I've drawn those on both graphs here. And we want to find the graph of the absolute value of that quadratic function and the reciprocal. And we want to make sure we understand how to deal with both. Okay, the absolute value is something that we don't really need to focus on, but we definitely need to know the reciprocal. Okay, so looking at the absolute value graph, what we're going to do is we're going to take everything that inside that's negative and make it positive. Well, that means that this part here is underneath the x-axis. All that has to change. That is going to be converted to its positive. So I'm just going to, so that you know how I got the original graph, I graphed the zeros at -2, +3, y-intercept, and I found another symmetrical point here because I know that the vertex is kind of right at +1/2. So I just graphed another symmetrical point, a couple symmetrical points up here. So once I've established the idea of absolute value, the inside, when the inside is negative, which I've highlighted in green, when it's negative, we need to convert it to its positive. So -6 becomes now +6 up here. Actually, I'm going to change color. It's going to be +6 up here. You know, we got another point over here. And just going to reflect those points up. And basically, all those points get reflected now that way. So my new graph is going to be this graph here. It's going to be this part. I'm going to maybe highlight that. It's going to be this part here. It's going to go bounce back up, back down, and back up. It's going to be that W-shaped graph. So that's what an absolute value graph is going to look like. The reciprocal one is the one that we really need to make sure we understand. This is on the final exam. And the reciprocal is going to be based on the denominator equaling 0, or the fact that it can't equal 0. So where the f of x is equal to 0 is right here and right here. Where they're equal to 0, when we do the reciprocal, we get the 0 in the denominator, and that gives us a vertical asymptote. We can't have that happen, and a 0 in the denominator can show up as a vertical asymptote. The other part of the reciprocal function that we want to be able to graph is the idea of the reciprocal relationship. So as something goes up, the reciprocal goes towards the x-axis. As we go away from the x-axis, the reciprocal should go towards the x-axis. Okay, this is a principle that we're going to use to draw the rest of this graph. There are invariant points, but in this example, it's hard to find the invariant points. The invariant points are where y is equal to 1 and -1, and that's where the graphs don't change. Okay, because if I take the reciprocal of 1 and -1, it doesn't change. Now, to graph this then, what we want to do is take that, now I need to just maybe draw this a little bit neater here. Okay, move my asymptote over just slightly, because at y equals 1, it's going, as it gets closer to asymptote, the blue graph goes towards 0, so the reciprocal needs to go away from 0. As I go in this direction, the blue graph is moving away, so the reciprocal should move towards 0. Okay, so for this part here, I need to move towards the 0, and as it goes away, it's becoming a horizontal asymptote. As the graph shoots away, it's going to get closer to 0. And we're just going to do the symmetrical part on the other side here. So same thing's happening. It's going to go along the asymptote and then towards 0. Oops, that's not a very good graph. It's going to go towards 0. Get closer and closer to 0. In the middle, we see it's going away, so we're going to go towards. Okay, it's going to go, so at -1, we're going to have something there, and then it's going to follow the asymptotes, and then it's going to go towards 0 as the vertex part there is furthest away, where this is where it's the closest to the 0, it's going to go through our -1, and it's going to go follow the asymptote here. So as the original graph heads towards the 0, the reciprocal graph's going to go up or down, in this case, along the asymptote. So this is what the reciprocal graph should look like. It's what I've drawn here in the green with those vertical asymptotes at the original 0 points. So the keys are the vertical asymptotes. Those are very important to be able to draw in, and then to be able to use a reciprocal relationship to draw the rest of the graph. The reciprocal of a parabola is going to give us this kind of patterning that we see here. Okay, lastly here we're going to graph the absolute value function. Now we can graph it as a piecewise function, as we've done we came up with piecewise equations up here. Where is it? And we can graph things with a piecewise, but really we can also graph this by just recognizing it's just a basic v function. Okay, so this is a basic v function, and the vertex is going to be the same as what we had in parabolas. So although it's not a parabola, it's still in the graphing form, and though the 4 and 6 represent the vertex. So the vertex is going to be at +4, +6. Okay, just like with parabolas, they're exactly the same because it's in the graphing form. It's going down, so it's going to be a V going down. So at +4, +6, +6 is right there. We're going to have an upside down V function. Okay, so now we want to use that vertical expansion of 3. And we can use that vertical expansion of 3 by, and I'm just going to maybe highlight that there. Actually, maybe I'll use a different color. We're going to use that vertical expansion of 3 by going, instead of 1 over 1 down, which we would normally do to get a regular V graph like that, we're going to expand that vertically, and instead of going 1 over 1 down, we're going to go 1 over and 1, 2, 3 down to that point. We're going to do the same on the other side. And what ends up happening is we get a much steeper V. Okay, and if you take a look at the slope of that V, the slope of that V is going to be -3. It's going to go 3 down like that. Okay, I think I've got that slope correct. Yeah, pretty much correct on both sides. And that gives us now that same function. We could do this as a piecewise function and work it out that way and work out the domain, but we know the domain boundary is x is bigger than or equal to 4 for the positive, and actually maybe I'll do that for a different color here. For the positive, x is going to be x is greater than or equal to 4, and for the negative, x is less than 4. Well, we can see that that's our boundary at x equals 4. And that's where it transitions from one part of the graph to the other.